Hello everyone. So today in this session we will be doing part two of the complex number. Here we will be talking about conjugate of a complex number. In previous classes we have seen the concept of addition, subtraction, multiplication, and division. So in this part two, I'll be telling you the concept of conjugate of a complex number. So let's say you have a complex number like 3 plus 4i. Okay, so if you want to find the conjugate you have to use this bar sign, so we call it z bar. So z bar will become 3 minus 4i. Okay, so and let's say if your z is 4 minus 4 plus 6i, then or let's say 4 minus 6i, z bar will become 4 plus 6i. Okay, and as you see all these theorems will be applicable. Like you if you see here, uh, let's say let's say talk about this z1 plus z2 and the whole bar is there, so that will be equal to z1 bar plus z2 bar. So you can prove it. You just take let's say you want to prove all these theorems, right? So you can take any, like you can call z1 as 3 plus 4i, you can call z2 as like 4 plus 3i. Okay, so let's say I'm talking about 7, so z1 plus z2, add it, so it will become 7 plus 7i. Okay, and if you do the bar of that, so 7 plus 7i bar means 7 minus 7i. So 7 plus 7i is like, you know, you want to prove now that 7 minus 7i is equal to z1 bar plus z2 bar. Okay, so what you can do, you find now z1 bar plus z2 bar. Okay, so you see here z1 bar is how much, 3 minus 4i, and just plus it. Then z2 bar is here 4 minus 3i, 4 minus 3i. Now if you add it, 3 plus 4, 7, and this minus 4 and minus 3, that is minus 7i. So you see here 7 minus 7i is coming, right? So z1 plus z2 bar is equal to z1 plus z2 bar, the whole bar. Okay, like that you can prove for all this, till 10. Okay, and you can do a lot of questions based on that. Okay, next concept I can tell you is that modulus. Okay, so like modulus of a complex number is like, let's say z is a complex number having 3 plus 4i. Okay, if you want to find the modulus, it has been denoted like this, z, like this, and then that is equals to square root of real value. Okay, so real value square plus imaginary value, which is 4, 4 square. Okay, and the whole square root. So that is, you see how much it is coming. It is 9 plus 16, and this is 25, right? So it is 5. Okay, so the answer will be 5. I hope it is clear, right? So this is called modulus of a complex number. So here also, whatever the theorems you can see here, like there are a lot of theorems. No need to remember anything. If you remember, tomorrow you'll forget. So it's better to use it. I mean, while doing the sums, if you keep doing the sums, it will be remembered by default. Okay. So like you see here, this is the second one I'm talking about. So there is a theorem called bar z is equal to sorry, this is modulus, right? Modulus z is equal to z bar modulus, okay, is equal to minus, like this. So you can prove it. How you can prove it? So let's say uh, you have a complex number. Just 1 minute. Let's say you have a complex number like 3 plus 4i. Okay. So mod z of this just we just found it, right? 5 above here. See, 5, same complex number it was, right? Now uh, now we, let's say we want to find uh, bar first. Let's say bar of this and modulus. Okay, so bar of this and modulus means uh, So z bar will be 3 minus 4i, and if you find the modulus of this, again it will be 5. Okay, in the same way you can find this one, this value. So minus z bar. Okay, so that will be coming minus z. If you do that, will become minus 3 minus 4i. Okay, and then if you find the modulus of that, so modulus of means what? Minus 3 square minus 4 square square root, same again 5 will come. So everywhere you see 5 is coming, right? So like that you can prove it. Okay, no need to remember everything, anything. Okay, and there are a lot of sums. Based on that you can, uh, practice. This is actually RD Sharma. You can prepare from, you can do some illustrative questions, then you can go into examples. So here, in this next, I'll be telling you reciprocal of a complex number. Let's say if you want to find, if you have a complex number z, how to find 1 by z. Okay, so it's very simple. Just do 1 by z. Okay, and find the solution. So let's say z is 3 plus 4i. Okay, so 1 by z will become 1 by 3 plus 4i. Okay, and just multiply like this: 3 minus 4i divided by 3 minus 4i. Okay, so just this is numerator and denominator will be multiplied. So 3 minus 4i divided by a plus b a minus b. So 9 minus, that will become 4i square, right? So 16 and I square minus 1. So 3 minus 4i divided by this minus and minus become plus. So 9 plus 16. So 3 minus 4i divided by 25. So 3 by 25 minus 4i by 25. So this is the value of the reciprocative of that particular complex number. Okay, so like that it should go. Now in the next session, I'm going to tell you, that will be part 3. So in that part 3 I'll be telling you the polar representation of the complex number and couple of hard problems. Okay, which while doing you might feel like it is tough. Those things we will solve. Okay, and then yeah, I think in part 3 mostly I'll cover that. Okay, if anything is left, then I'll try to make part 4 of this. But yeah, mostly I'll try to make it in part everything in part 3. Yeah, that's it. Thanks.